Hello, welcome to another of my videos where I work through and explain AQA A-level Physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer D, well done. If you didn't and you'd like to hear my explanation, please continue watching. So we've got an isolated spherical conductor, a charged isolated spherical conductor. I'll call it a charge Q. The conductor has a radius R and an electrical potential V. The electrical field strength at its surface is E. So I'm going to call these first conditions condition 1. I'll call that radius 1, initial electrical potential V1, initial electrical field strength we're interested in E1. Point T is a distance 2r from the surface. What are the electric field strength and electrical potential at T? So I'll call that the potential V2 and the electrical field strength E2. Now, a really important thing right from the start, we need to notice that this distance is 2r from the surface, but it's 3r1 from the centre of the charge, and that's the important thing when we're doing out any calculations, how far we are from the centre of the charge. So there are many ways of approaching this question. I'm going to show you what I think is probably the quickest way of doing it. So the first thing is I'm going to decide what equation I'm going to be interested in, and the first equation for the electrical potential is V is equal to 1 over 4 pi epsilon 0 Q over R. Q is the charge and R is the distance from the centre of charge. Well, I'm not going to change any of this constant term, so I'm going to ignore that. And I'm not going to change the charge in this particular question, so I'm going to ignore that. So for conditions V1, I could say that the potential at V1 is proportional to 1 over, and the distance in condition 1 is capital R1. For conditions 2, the electrical potential is proportional to, well, again, I'm ignoring this constant term here. I'm ignoring the charge. What I can say is that V2 is going to be proportional to 1 over, and again, that distance now is 3R1. Now, if I look at the ratios, I can say that electrical potential V2 over electrical potential V1 is equal to, well, V2 was 1 over 3 R1. V2 is 1 over R1, which is the same as multiplying the reciprocal of that. Now I can cancel the R1s, and that will leave me V2 over V1 is equal to 1 over 3, or V2 is equal to V1 over 3. Well, that's actually the only option, so it has to be D. But let's go through using the same idea to work out the electrical field strength. My equation for electrical field strength, again given on your data sheet, electrical field strength is 1 over 4 pi epsilon 0 multiplied by the charge, and this time over the distance from the centre of charge squared. Again, we're not changing any of those numbers, we're not changing the charge. So for the first condition on the surface of the sphere, the electrical field strength is directly proportional to 1 over R1, but this time squared. And at this point T2, the electrical field strength is going to be proportional to 1 over, again, it's really important that we use the distance from the centre of charge, and that is 3 R1, all squared. Again, I can take the ratios of E2 of over E1. E2 is 1 over, and I'm going to multiply out this bracket. So 3 squared is 9, multiplied by R1 squared. And again, I'm going to divide by E1, so I'll multiply by the reciprocal, R1 squared over 1. I can cancel those R squareds, and I can rearrange to say that E2 is equal to E1 over 9. Well, there's the only option. So, answer D. I hope you found this useful. Please do leave a comment. Perhaps there's a question you'd like me to go through.